Okay, today we're starting chapter 4 in probability. So, probability. We define it simply as just the numeric value representing the possibility that some event will occur. So, we could be interested in anything. What's the probability it will rain tomorrow? What's the probability that I will win a game of poker with, say, a full house? What's the probability a stock will increase tomorrow? We could be interested in anything. And we have three different types of probability, as at least as defined in our book. So the first is a priori. This just simply means that any probability is based on prior knowledge. So going back to the deck of cards example, I already know that half the deck contains red cards and the other half of the deck contains black cards. So let's say I'm interested in the probability of drawing a red card, probability of drawing a red, would just simply be 50% because I already knew before I drew a card from a deck of 52 cards that half of them are red. And so my probability would be 50% based on my prior knowledge of a deck of cards. Our second type, empirical, and this is a probability based on observed data. So let's take an example. Let's say I was interested in how many St. Vincent students prefer the calf versus the shack. So I don't know, I go out and I survey some amount of students. And in my survey, 60% said they preferred the calf compared to the shack. And so let's say I was interested in the probability that a student prefers the shack. Well, then I know it would be 40%. Because if 60 preferred the calf, that means 40% must prefer the shack. And we call that empirical because we actually went out and collected data and then formed a probability around that observed data. So we call that empirical. And then finally, we have subjective. Subjective. And this is the probability based on any individual person's opinion. So let's take an example. Let's say I believe the probability that my business will succeed is about 70%. Now, ideally, I would have good reason for that because I'm involved with the business and I might have a good idea as to how likely it is to succeed, but it is ultimately my opinion. Whereas, say, my business partner, they might believe that the probability of success is only 60% compared to 70. And so when we think of subjective, it's someone's opinion, so it can vary based or from person to person. So let's get through some definitions. Let's start with the idea of a sample space. Sample space. And a sample space is simply the collection of all possible events or outcomes, say within an experiment. So let's take an example. I could toss a coin, right? When I toss a coin, there are only two possible outcomes. You can either get a heads or you can get a tails, and that is it. So when we think about the collection of all possible events, it's either heads or tails. There are two events that make up the sample space when tossing a coin. Or we could say, roll a six-sided die. So the collection of all events, in this case, would be the numbers 1, 2, 3, 4, 5, and 6, because those are the 6 possible outcomes that you can get when rolling a six-sided die. But we're generally interested in an actual event. An event is just all of the outcomes described by some characteristic, and we can denote this, say, event A. Event A. So let's return to our examples. We have tossing a coin. I might be interested in the event heads. Event heads. So there's only one outcome associated with this event because there's only one way to obtain a heads when flipping a coin. Or let's think about rolling a six-sided die. I might be interested in the event even. And there are two possible outcomes, or rather three possible outcomes, because I could get a 2 or a 4 or a 6. So there are three outcomes associated with the event even when we are rolling a six-sided die. And when we think about the idea of a complement, complement is simply all of the outcomes that are not in event A. And we denote this as just A with subscript C or just subscript prime. So that means A complement. So when we think about the complement of the event heads, it's tails, right? Because when we flip a coin, it's either heads or tails. So if you all of the events that are not heads is then tails. Similarly, with toss or rolling a die, the complement of the event even would be odd, because even represents the numbers 2, 4, and 6, and so not that would be the outcomes 1, 3, and 5. So now we're ready to define the probability of an event A. It's probability of some event A, so I'll just write it as P and then whatever event within parentheses. And it would be the number of outcomes in event A divided by the total number of outcomes. So we could think about this denominator as our sample space, all possible outcomes or events. And then we define the probability of A complement. The probability of A complement is just 1 minus the probability of A, because a probability of some experiment must be equal to 1. We must have observed some event. And so if we're interested in the probability of not A, then it's simply 1 minus the probability of that event A. Okay, so let's do some examples. Let's start with tossing a coin and obtaining heads. So the probability of tossing a coin and obtaining heads. So let's start with the denominator. Let's again think about the total number of outcomes. So how many total outcomes are there? There are 2, right? You can either get heads or tails. And then thinking about the event A, the number of outcomes in event A. Well, in this case, it's just 1, because there's only one way to obtain a heads. So that would be 1/2, or 0.5, or 50%. How about rolling a die and obtaining an even number? Okay, well, we already determined there were 6 ways, 6 total outcomes, right, in the sample space, 1 through 6. So we know that there are 6 possible outcomes. And how many of them are even? Well, we determined there were 3 different outcomes, 2, 4, or 6. So there are 6 possible outcomes from rolling a die. How many of them belong to event B or an even? And that would be 3. So 3 out of 6, which is also 1/2. How about rolling a die and obtaining a 5? Well, there are still 6 possible outcomes from rolling a die. And how many ways are there to obtain a 5? Well, that would just be 1, or 1 out of 6. And then the probability of C complement, or not a 5. So we could define this as 1 minus the probability of C. So that would be 1 minus 1/6, which would be 5/6. How about rolling a die and obtaining a number no larger than 2? So no larger than 2 would include the outcomes 1 and 2. So we still have 6 total outcomes, but we could get a 1 or a 2. Those would both belong to event D. So we have 2 outcomes, 1 or 2. So 2 out of 6 would be the same as 1 out of 3, 0.33, or 33%. And then the probability of D complement. So again, 1 minus the probability of D, and that would be 1 minus 1/3, or 2/3, or 67%. Okay, and that, actually I should assign probabilities to these up here. So 1/6, if we put that into our calculator, I get 0.167, or about 16.7%. And so that means 5 out of 6 would be 0.83, or about 83%. And this was also 50%. Okay, so that's our introduction to basic probability. And in the next video, we will do some additional practice.